This is a demonstration of the widgets demo in the Intelligent Equipment Accelerator. This is also the same demo as in the High-Tech Manufacturing Accelerator, as it shows a series of factories with some production lines. I'm going to log in here and you can see my factories on the map. And what I'm going to do is I'm going to go ahead and start a simulation. And this is going to be generated data, so it gets generated on the fly as the simulation runs. So now you see we have some production lines that have come up here as well. These metrics that you see are generated on a 10-second interval, so it may take a couple of those intervals to elapse before we start to see those metrics being populated. There we go, we're starting to see some numbers come up. So these are the various components of overall equipment effectiveness, or OEE. So the OEE is the multiplication of these three values together. So availability is the amount of time that the line is up versus the amount of production time that's available. So if we're up for only 6 hours of our 8-hour day, that's how you calculate availability. Performance is the amount of time it takes to produce a unit. So our ideal cycle time in this case is 5 seconds per unit. And if we take 10 seconds, then our performance is going to be adversely impacted by that. And then quality is the number of units that we produce that are good versus the amount of units that we produce in total. So 60% of what we're producing here is good units. All of these multiplied together is giving us a 20% OEE at the moment, which isn't great. So let's drill down and have a look at what's going on inside of this line. So here we've got some properties of the line, the product that we're producing, no alerts. This is an indication of the number of units we've produced, good versus defective. And here's our OEE. Now the availability is shown on this status events panel, our uptime versus downtime, and we can see the different reasons why we're having downtimes here. Our quality is reflected by this chart, and our performance is actually the amount of time it takes to produce a part versus the ideal cycle time up here. We can look at the history of the OEE over time by selecting this panel. You can see here on the left we have a representation of what the production line looks like. These are the various bits of equipment that's part of the production process. And this layout here is configuration driven. So if I go back to the Incheon factory and pick a different one, I'm going to pick line B here. You can see our layout is going to be different. I'm going to go ahead and pick the convection reflow oven. And you see inside of this we have a temperature device, and again we see the status, which is a summary of this particular piece of equipment inside of the production process, and then some additional information. You notice as well we've got a number of alerts here that are saying temperature over maximum. So let's drill down inside of the temperature and see what's going on there. So here's our data over time, and again bear in mind this is generated data, so it looks a bit noisy, but every time these readings go above the upper red line, which is the maximum value for this temperature sensor, it's going to raise an alarm. And that's done through a rule that we've built inside of Streambase. So if I go into Streambase Studio here, you can see my rule as I've defined it. This rule then gets deployed inside of AMS. I create a rule module inside of the accelerator, and then when I configure the temperature device type, which I've drilled down into here, I can attach that rule on here and say every time we do a temperature reading, I want you to check to see whether or not the temperature is exceeding the max, and if it is, then raise an alarm. I'm going to go back to the line and pick a different piece of equipment now. We'll have a look at the solder paste inspector. So this equipment has 3 devices associated with it: component clearance, substrate thickness, and volume. I'm going to go ahead and pick substrate thickness. And again, we can look at that data over time, current reading. And you'll notice there's an attribute here called readings over max count. This is currently down at the moment. When it starts again, this value will start incrementing. Every time there's a value that goes above the upper red line, this value gets incremented by 1. And again, this is a rule that's been implemented in Streambase. And this one's been done using decision tables. So I can go into AMS and log in there and look at the details of that decision table. So this is the actual business logic that determines whether the rule is firing. So in this case, if the value is greater than the upper value, I'm going to do two different actions: set attribute value for the exceeded max and the over max violations. These actions are done in another decision table, which in this case it does the condition and then it sets the values of attributes. And the one we're looking at there is the readings over max count. But if I go back up to the solder paste inspector, there's another attribute in here called substrate thickness reading exceeds max, and it currently says lots. And there's an additional rule in there that says if there's more than 10 readings above that upper red line, set this attribute to the value of lots. If I go back up to the overall view of the factories here, we can actually influence these metrics as the data is flowing through the system, and we can do that on a line-by-line basis. So if I open the simulation panel here and go production lines and pick Incheon line A, you'll notice our quality is currently 85%. What I can do is I can increase the defect rate up to 90%. And then what will happen is the quality is going to drop over time. So currently we're running on 1 times compression, so I'm going to increase that to 5 so that things start to happen a bit quicker. So you can see our quality is currently dropping. We can influence the performance and the availability as well. So if I go back into that panel, availability is influenced by the status up to down rate. But what I'll do is I'm going to change the performance and increase our cycle time from 5 seconds up to 54 seconds. And what that's doing is the amount of time it takes to produce a part is going to increase, and that's going to cause this performance metric to drop.